A concept design here. This one less aggressive. This one is going to be a little bit more explanatory initially. And should be something I feel would be a huge leap forward for us in our endeavors for better treatment of ailments, mental health, physical or genetic. So bear with me, okay? This one's going to be slower. It's going to be a lot nicerly put together, you know. Hopefully you won't get as triggered, if at all. Freaking Jesus Christ. But it's still raw dogging it, one-shotting off the top of my head like all the rest of them. No plans, no nothing, just going for it. Okay? So that's something. All right, it's a freaking microphone. All right. So the basic premise of this design is to solve some of the issues that we currently have with drug discovery, chemical analysis or discovery, or also genetic alterational treatments for Parkinson's, Alzheimer, longevity, death, treatments. Because death is definitely a disease. I don't care how many people have been conned into believing that that is a natural part of life. It doesn't need to be. It's a disease. So, especially if you're ever thinking about traveling among the stars and becoming, an interplanetary, interstellar, or interuniversal, skipping past, by that point, I would imagine, pretty quickly, the intergalactic side of things, which would be a brief part of our history, I would imagine. So there you go. Simply because of the discovery possibilities that would eliminate some of these ideas of the Kardashev scale ideas that have persisted without the explanation of the exponential curve change that is obviously going to exist as we discover more about our scientific theories and how best to engineeringly, creatively, scientifically come together and alter and manipulate the world around us more and more efficiently, and more effectively, and more powerfully and completely. All right. So the idea is as follows. Utilizing a basic idea, again, of taking a APU, like let's say a AMD, which hasn't been released yet, but it's coming out. It's an exascale APU, Instinct MI300, and taking that and utilizing a involved but still very feasible change to our motherboard processes to take the output and switch it over to a light-based photonic fiber optic laser / regular fiber optic network analog style computational design to help set up standard, more powerful computational quantum qubit computers. Many of them resultively working together in parallel with automated processes to extract the information as precisely and as quickly as possible. So the human element is taken out, and the setup for that information with multiple of these quantum qubit computers staged together to allow for error correcting to their qubit systems. Then that getting utilized to feed the next APU to analog / informational fiber optic networks. That would be advantageous in a hybridizational process to speed up very complicated design problems, mathematical problems that typically take an exceedingly long period of time to be any kind of decent accuracy and certainty of for chemical analysis, drug analysis, and genetic alteration analysis. Because they're predictive, and so quantum qubits are very, very good at what they do, very fast at what they do, but they're not very many, and we don't have a good amount of stability, and we don't have a good amount of error correcting, and we don't have the speed that we're looking for. And so we're changing our qubit philosophy currently to something different that, while not as powerful, is more able to do more quickly. And so going back to those more powerful setups will allow for us, by crunching large amounts of data analysis ahead of time, to effectively compress in the computational analysis for those qubit systems to be more efficient and effective at their utilization very quickly for these types of tasks, while still remaining fairly cost effective. Now, my design is a little bit flawed. Okay, I will readily admit that. As a current system has not been put together to efficiently, automatically extract information for qubit computer systems that are readily commercially available. So we're talking really realistically about an engineering team set up, designed just for that task. Same thing with APU, exascale, massive amounts of overhead cost on that. But here's the pitch. The basic pitch is you will receive very quickly a monetary advantage on other competitors that are not doing this. That and a very significant benefit to humanity doing that. The basic premise is leveraging a informational, computational setup that is more, with these APUs, complex, trigonometry, calculus, or other styles of computational analysis, into a more paralleled GPU, which is part of the APU analysis, to basically crunch back and forth these very complicated mathematics in massive arrays for neural network analysis, for system analysis of our bodily functions of a given chemical and its cascading domino effect over time for the entirety of our bodies and or neurological setups, genetically, alongside of regular organic sequencing. Now, the reason why you want to have a series of computational qubit computers that are much more readily and able to be more powerful and are much easier is the best method I can propose for this kind of a setup is a liquid nitrogen overclocked exascale APU design, thus helping reduce with a liquid helium design the overhead cost of maintaining the liquid helium, liquid nitrogen, because if we can do it with a large hadron collider, I'm fairly certain we can figure out how to overclock and manage liquid nitrogen and helium for this process. It's the automation process, which currently, I believe, has been done, but just on small scales. We are talking about a few people that have done something that worked. But people are creative, and engineers are totally capable of coming up with their own designs that are even better. So the process for the fiber optic laser network is the reason why I want to do this, is because it allows for the setup of those qubits by using the crunching of the data by these exascale computer model systems to set up these other error-correcting multi-stage qubit systems. Allows for them to, once extracted knowledge has become available, that goes back into crunch analysis for the next setup of banks of computer servers, which then is it's a supercomputer. It's a supercomputer to just make the qubit systems far more feasibly and more relevantly able to come into the server supercomputer space and be worthwhile as an investment. And then that can run as necessary, and eventually that automated process, hopefully, will be able, if it's done correctly, set up for the next set of calculations for their qubits and error-correcting qubit systems in their paralleled manner, hopefully getting a great enough degree of accuracy to believe with a high enough degree of certainty that it's acceptable to continue on with the next supercomputer bank. Upon doing that, then it's able to run as a genuine, actual, connected, hybrid qubit quantum computer and supercomputer traditional setup that hopefully, because qubit systems are extraordinarily powerful with predictive computational analysis for the kinds of systems I'm talking about, simply because they automatically do a cascade domino effect analysis computation methodology, and therefore will massively speed up the process of these drug discoveries, treatment discoveries, genetic alteration discoveries for treatment to various ailments that we currently are kind of hitting our heads against the wall. And it's a way to speed up and be more certain that testing these drugs for our research and development as a pharmaceutical company or the government or, let's say, military decide to get involved, or regular people that wanted to simply just invest, would find that they could bring to market a genuinely positive treatment that they were certain would go through trials effectively and efficiently with very well understood, to a high degree of certainty, effectiveness and reduced cost for creating these treatments, these medicines or chemical or genetic alteration systems, making it more cost effective, especially long term, as upgrade paths are available over time, allowing for us to do even better for that process. It's a fairly simplistic yet complicated. It's very extreme on both ends. As a complicated design, it's not. It's a very efficient, simplistic design. On the other hand, it's also very complicated programming and methodology-wise, automatively, and engineering-wise to maintain not so much the helium or nitrogen, it's to consistently keep it going in the correct amount of server banks, and having it be computationally working hard enough during the APU area such that that amount of time and effort and energy and work done is timed appropriately for the start to have been ready for their next phase of calculations, which is a definite balancing act. However, you'll see a return on investment. In fact, I don't see why that wouldn't be the case. Most computer-aided design buildings, parts, analyses are, on a whole, much more likely and readily able to come together, so long as there weren't faults in programming or bugs in how it is they set up what they were trying to put together, more efficiently and readily, with less waste and less cost waste. So I believe that would definitely be a benefit wholeheartedly for that entire sector. This is Xenon Reality, John Tyler Limke, if you know me personally. And there you go. Have fun. I hope at some point I'll be able to be a part of something like that coming together. Bye.